All right, welcome to the deep dive, where we like to take some topic that people are really interested in and extract the essential knowledge that you need to know about it.
Yeah.
Because, we all want to be in the know, we want to be informed, but sometimes there's just so much information out there. So today, we're diving deep into penicillin.
Yeah.
A true turning point in medical history, right?
Absolutely. I mean, it wasn't just a new medicine. It ushered in an entire era, the antibiotic era.
Right.
And it's something that completely changed the way that we deal with infections and still has an impact today.
It's hard to imagine a world before, right?
It really is. And I think, for you, for the listener, I think grasping that shift from before penicillin to after penicillin is key to understanding just how far we've come in healthcare.
Absolutely.
And so we've gathered, a variety of sources, both historical accounts and scientific information, to try to give you a picture of how revolutionary this was.
Absolutely. And our mission is to cut through the complexity. Yeah.
To really give you the core story. So how was it discovered?
Right.
How did it go from just this lab curiosity to something that was, widely available, widely used? And what was the impact? Maybe a good place to start is to try to picture a world before penicillin, a world where even the everyday infections that we barely even think about
Right.
could be really, really dangerous, even fatal.
Yeah. Absolutely. It's easy to lose sight of this, but in the pre-antibiotic era, infections were one of the leading causes of death.
Yeah.
Just think about it: simple wounds, childbirth, even minor surgery.
Right.
These things all carried a very real risk of a deadly infection. And then you have diseases that we now just routinely treat: tuberculosis, pneumonia, syphilis, even strep throat.
Right.
These could often be a death sentence. And I think understanding that, that pre-antibiotic world, it really highlights that, kind of a fundamental fragility of human life.
That we just don't really have to face in the same way anymore.
Yeah. Yeah, it's interesting because we've made, obviously we have antiseptics thanks to Lister,
Right.
which, was a huge step in preventing infections during surgery, but that didn't help with infections that had already taken hold.
Yeah, once it's in the body, you didn't have a lot of options.
Yeah. So you have these herbal remedies, bloodletting, things that, maybe offered some comfort, maybe did a little something.
Right.
But they weren't targeting these bacterial infections.
Exactly. They didn't have a way to sort of systematically target those bacteria.
Right. And it's interesting because at the same time, you have people like Pasteur and Koch working on germ theory.
Right.
So they're establishing that, okay, these microorganisms are causing these diseases, but we don't have a good way to fight them once they're in the body.
Exactly. I mean, it was a time of incredible progress in understanding the causes of the disease.
Right.
But we really lacked the tools to effectively combat them.
Right. And that's where Alexander Fleming kind of enters the story.
Yeah, and he kind of stumbles into it, really.
Yeah.
It's one of those great stories of scientific serendipity.
Yeah, in 1928, he's at St. Mary's Hospital in London working with Staphylococcus aureus.
Right.
Goes on vacation, leaves some petri dishes lying around.
Yeah.
Maybe not textbook procedure, but
Yeah, maybe a little bit of not following the strictest protocols.
But this is where the happy accident comes in.
Right. He comes back. He finds that one of his dishes is contaminated with mold.
Right.
And here's the thing. Around the mold, he noticed that the bacteria weren't growing.
Right.
And again, it's not just luck here. It's Fleming's trained eye, his understanding of bacteriology,
Right.
that allows him to see this as something more than just a contaminated experiment.
Right. So he sees this zone around the mold, and the bacteria is not growing there.
Right.
And he identifies the mold as Penicillium notatum.
Right.
And then he actually takes this crucial step of extracting the substance that's killing the bacteria, which in his early tests, he finds it seems to be safe for human cells.
Right.
And he names it penicillin.
Penicillin. And I think, what's so fascinating about this is his scientific curiosity.
Right.
I mean, a lot of researchers would have just looked at that contaminated culture and just tossed it out.
Right.
But he recognized that there was something unusual, something potentially important happening, and he pursued it.
Right, right. So his initial experiments show that it's effective against several types of bacteria.
Yeah, some really nasty ones too. Streptococcus, staphylococcus, diphtheria, bacilli.
Right.
Um, so, he was seeing that this could potentially be a really powerful tool against some serious diseases.
Right. But, as we know, it doesn't immediately become this widely used drug.
Yeah.
He runs into some problems.
Right. I mean, he had a lot of trouble producing it in large quantities.
Right.
It was unstable,
Yeah.
difficult to purify. And so, he publishes his findings in 1929, which is an important step,
Yeah.
but it doesn't lead to this immediate medical revolution.
Right. So it kind of sits there for a while.
Yeah, it kind of languishes for about a decade.
Yeah.
His findings are out there, but they're mainly in the scientific literature.
Right.
It's not until the late 1930s that a team at the University of Oxford, led by Howard Florey and Ernst Boris Chain,
Right.
really kind of pick up the torch and revisit his work. And I think that's an important point too, right? Sometimes, revisiting this research that seems to have stalled
Right.
can lead to these really transformative results.
Yeah. It's not always the initial spark of genius. Sometimes it's that second look.
Right, that second look, that fresh perspective.
Right, right. So Florey, Chain, and their team, they take on this challenge, and it sounds like their main goal was to figure out how to extract and purify penicillin, to make it stable, to make it something that could actually be used.
Right. I mean, that was the big hurdle that Fleming had run into.
Right.
Um, and it was a really, really difficult problem. I mean, there were significant scientific and technical challenges to figuring out how to isolate and concentrate that active compound.
Right.
But they stuck with it. And,
Yeah.
and their perseverance paid off.
Right. And then this pivotal moment comes in 1940 with their experiments on mice.
Right. And this is a really crucial moment because it's one thing to show that penicillin can kill bacteria in a petri dish.
Right.
But it's another thing entirely to demonstrate that it can actually work in a living organism.
Right, to treat an actual infection.
Right. And so these experiments on mice, these really unequivocally demonstrate penicillin's effectiveness.
Right.
I mean, they were really powerful proof that this could work.
So that was a huge step. But then there's the human story.
Right.
In 1941, they do the first human trial.
Right. And this is where it really gets, I think, really hits home the potential of penicillin.
Mm-hmm.
So this first trial involves a policeman who has this very severe, life-threatening infection.
Okay.
And they give him penicillin. And the results are, at first, remarkable.
Right.
I mean, he shows significant improvement.
Right.
He starts to recover. And this is just with the limited amount of penicillin that they had been able to produce at that point. But tragically, their supply runs out before the infection is completely cleared.
Oh, wow.
And he eventually dies.
Wow.
And it's a really heartbreaking case, but it also really starkly illustrates just how desperate the need for penicillin was.
Right. It shows that, yeah, the science is promising,
Yeah.
but the ability to actually manufacture this at scale,
Right.
that's the big bottleneck.
Yeah.
And then World War II starts.
Right.
Which just makes the need even more urgent.
Absolutely. I mean, suddenly you have this massive increase in the number of infected wounds among soldiers.
Right.
And so the British government, they see the potential of penicillin to save lives.
Right.
And they reach out to the United States for help.
Right.
And this is a really crucial moment of collaboration. You have researchers and pharmaceutical companies
Right.
In both countries coming together to try to figure out how to scale up production.
Right. Right. So it's not just a scientific challenge anymore. It's an engineering challenge.
Exactly. It's figuring out how to take this process from the lab
Right.
and turn it into something that can be done on an industrial scale.
Right. Right. And that's when we see these big innovations in how penicillin was made.
Yeah.
So instead of small cultures, they're moving to these huge tanks, right?
Exactly. They developed this technology called deep fermentation,
Right.
which basically involves growing the penicillium mold in these large submerged tanks.
Wow.
And they have to really carefully control the conditions in those tanks.
Right.
But this allows them to produce much, much larger quantities of penicillin. And there's another kind of amazing twist to the story here,
Okay.
which is the discovery of a more potent strain of penicillium
Right.
on a moldy cantaloupe
What?
in Peoria, Illinois.
Wow. You really can't make this stuff up.
Yeah, I mean, it just goes to show you that scientific discoveries can come from the most unexpected places.
Absolutely. Absolutely. A moldy cantaloupe helping to save lives. So this new strain, along with these improved fermentation techniques, this finally allows them to mass produce penicillin.
Right.
And by D-Day, 1944, Penicillin was widely available to the
Right.
Allied troops, and it's no exaggeration to say that it saved countless lives.
Right.
It dramatically reduced the number of deaths from battlefield infections. It was really hailed as a miracle drug.
And it had a huge impact on the war effort.
Yeah. It's hard to overstate the impact of penicillin. I mean, it didn't just treat infections, it really changed the way we think about medicine. It was the start of the antibiotic era.
Absolutely. It took these diseases that had been, leading causes of death
Right.
and transformed them into treatable conditions.
Right.
And so it really fundamentally changed the way that we think about infectious diseases.
Right.
And of course, this success, it didn't stop there.
Right.
The discovery of penicillin, it really ignited the search for other antibiotics.
Right.
And so soon after that, you have the discovery of streptomycin, which is effective against tuberculosis.
Right.
And then you have tetracyclines, cephalosporins. And so suddenly our ability to fight bacterial diseases just expanded dramatically.
Right. And it also really fueled the growth of the pharmaceutical industry because penicillin really showed the potential of drug development, both for public health, but also as a viable industry.
Exactly. I mean, it really showcased the power of pharmaceutical research and development.
Right.
And led to really significant investment in this field.
Right. But of course, like any great scientific story, there are complexities and challenges that come with it.
Absolutely.
And one of the questions that I think comes up a lot is who really deserves the credit?
Right.
Is it Fleming for the initial discovery?
Right.
Or is it Florian Chain for actually making it into a usable medicine?
Yeah, and it's a really, it's a complexity. I mean, there's no doubt that Fleming's initial observation was absolutely crucial.
Right.
But Florian Chain and their team, they're the ones who really figured out how to extract it, how to purify it, how to prove that it was effective in living organisms.
Right.
And, the Nobel Prize in Physiology or Medicine in 1945 was awarded jointly to all three.
Right.
Which I think recognizes the fact that scientific progress often builds on the work of many people.
Right. Absolutely. And then, of course, there's the really serious issue of antibiotic resistance, which is something that we're still dealing with today.
Absolutely. I mean, it's one of the big challenges of modern medicine.
Yeah.
And, it's almost ironic, really. The penicillin was so effective.
Right.
It was used so widely that it actually ended up driving the evolution of resistant bacteria.
Right. Because bacteria, they adapt, they change.
They do. They're very good at it.
Yeah.
And so, these bacteria, they evolve mechanisms to evade the effects of the antibiotics.
Right.
And so this means that infections are becoming harder to treat.
Right.
Diseases like gonorrhea and pneumonia, which used to be readily treatable with penicillin,
Right.
we're now seeing rising levels of resistance. And it's a really, it's a sobering reminder that we're in this constant evolutionary arms race with these microbes.
Right, right. So this miracle drug, it faces a threat from the very organisms that it's supposed to be fighting.
Exactly.
Wow. So, I mean, looking back at this whole story, it's really quite incredible.
Yeah.
Are there any key takeaways that you think we can learn from this?
Yeah, I mean, I think there are a few that really stand out. First of all, I think Fleming's experience really highlights the role of serendipity and scientific discovery.
Right.
So this element of chance, the unexpected observation. But it's also a reminder that it's not just about luck.
All right.
It's about having that prepared mind. It's about that scientific curiosity, those sharp observation skills,
Right.
the willingness to pursue an unexpected finding.
Right. To not just dismiss it as a mistake.
Exactly.
Right. Right.
And then, another takeaway is the importance of collaboration. I mean, the development and the widespread use of penicillin was really a triumph of international collaboration.
Right.
You had scientists, governments, industry, all working together
Right.
to address this global health crisis.
Right.
And I think that's a really important lesson for all of us, in any field, but especially in science.
Right.
And then finally, I think the challenge of antibiotic resistance.
Right.
This really serves as a reminder that even the most transformative breakthroughs
Right.
require careful management, a sense of collective responsibility.
Right.
And it's something that we all need to be thinking about.
Right. Absolutely. So, I mean, It's really quite an extraordinary story, right?
It is.
From a forgotten petri dish to saving countless lives. I mean, penicillin really was a watershed moment, not just in medicine, but in our understanding of what's scientifically possible.
Absolutely. And, I think it's a journey that really underscores that scientific progress is not just about these initial flashes of insight,
Right.
but it often involves decades of dedicated work, overcoming really difficult technical challenges, the collaborative efforts of many, many people.
Right, right. So for those of you listening, next time you see something that's a little bit out of the ordinary,
Yeah,
don't just dismiss it.
right.
Think about what it could mean.
Yeah, what could be hiding there? What secrets could be lurking beneath the surface?
Absolutely. And how your own curiosity,
Oh,
your own, willingness to investigate,
right.
how that could contribute to the next big breakthrough.
Absolutely.
Well, thank you so much for joining us on this deep dive into the discovery of penicillin.
Thank you for having me. I enjoyed it.
It was fascinating.
Yeah.
And we'll see you next time on the deep dive.